Okay, we're ready to do 7.2. So let me get a whiteboard here. Pencil. All right, here we go. We're going to do 7.2, which is adding and subtracting rationals. So we are adding and subtracting fractions. So we're doing rationals or fractions with variables. For instance, 3y over 5 plus x over 5. Now, we know the rule is the denominator has to be the same and it stays the same, and then we take care of the numerators. 3y plus x is just 3y plus x. Cannot combine it. 5 is the denominator. It stays the same, and that's the answer. Now, if everything was that easy, wouldn't math be so much better? But it's not. So let's look at another one that's fairly simple. And the reason why it's fairly simple is because the denominators are the same. You don't have to change anything. Okay, denominators are the same. They stay the same. What is 7 minus 11? 4. Now, this is not done because all of this is being multiplied, and that's just one thing single. So everything is being multiplied. We don't have to put parentheses around anything, and we can reduce. And I've got a 4 and a 2, which becomes a 1 and a 2. So you got to remember to always reduce. And that gives me 2 over r squared. Now, again, we can look at something that is relatively easy because the denominator is the same. If the denominator is the same, it stays the same, and we add the numerators. And m plus p is just m plus p. Now, if you got this far, that's great. But what you have to realize is that this is the difference of two squares. M plus p, I'm going to put parentheses around it because the only way I can reduce it, because it's being added, is if I have something else that is exactly the same. And m plus m squared minus p squared actually can factor. It's the difference of two squares. Square root of m squared is m, the square root of p squared is p, and it's always plus and minus. Now, I have an m plus p and an m plus p. So when I reduce that, I am left with 1 over m minus p, and that's my answer. Okay? One more. Oops. This is x minus 2 over 3x plus 1. Now, the reason why this is on here is because what you need to see is that we are subtracting, and we are subtracting the whole thing, everything that's there. You have to be very careful with that. So the denominator stays the same, and it's 3x plus 1. But I end up with 7x minus x plus 2, which gives me 6x plus 2 over 3x plus 1. Combine like terms. But now look at this. 6x plus 2. Can I reduce that by taking anything out? I can't. I can take a 2 out of each piece here. Put parentheses around to know it's got to be the same. If I take a 2 out, I'm left with 3x plus 1. And on the bottom, I had 3x plus 1. Those cancel out. And my final answer is just 2. Okay. All right, let's look at one, though, that poses a different problem. Now I'm adding fractions that don't have the same denominator. I have to change them so that they have the same denominator. What is the common denominator for 8 and 2? 8. What letters are represented? P's. And what's the highest exponent? A 1. You know how to find a common denominator for numbers. I'm not going to go over that. That's something that you should already know. But with the letters, you just add every letter or everything, every piece with the letter that's there, and you use the highest exponent, which means I'm going to change things to that common denominator. That one doesn't change. But from 2p to 8p, I'm multiplying by 4. So I have to do the same to the top, and that gives me 20. Now the denominators are the same. I can add the numerator. It does not reduce, and I am done. All right, let's try another one. It'll start to make sense the more we do it, okay? All right, let's look at 1 over q minus 1 minus 1 over q plus 1. Now, these things are being added or subtracted, so I'm putting parentheses around them. Right now, the denominator has a q minus 1 and a q plus 1. And they are two separate things. You know they are because we couldn't reduce them if they were on top of each other. They are two separate things. It's kind of like saying you have an A and a B. So the common denominator is going to be q minus 1 times q plus 1. That's the common denominator. Now, if I were to go from here to here, what did I do? I multiplied by q plus 1. And whatever we do to the bottom, we do to the top. So what do I get when I multiply q plus 1 times 1? I get q plus 1, don't I? All right, looking at the second piece, to go from here to here, I multiplied by q minus 1. So whatever I do to the bottom, I have to do the top. Now, when I multiply on the top, 1 times q minus 1, I get q minus 1. Remember, we are subtracting. So the denominators are the same, and they stay the same. And I combine the numerators. I already have a q plus 1. Now I have minus q plus 1. So when I reduce that, q minus q is gone, and 1 plus 1 is 2. Nothing reduces, so that's my answer. All right. Let's look at, what if I had 3 over x minus 2 plus 5 over x minus 6 over x squared minus 2x. Put parentheses around it. 3 separate things. But I want you to look at, okay, is there anything I can do to this to change it? No. Anything I can do to that to change it? No. Well, what could I do here? I could take an x out, and I'd be left with x minus 2. So instead of that, we're going to look at this. Okay? Now, what would the common denominator be? Well, there are x's and there are x minus 2's. What is the highest exponent for the x? 1. And what's the highest exponent for the x minus 2? 1. So this is what we are going to change all the pieces into. Now, stop and look. To go from here to here, I multiplied by x. I multiply the top by x, and I get 3x. Next, to go from here to here, I multiplied by x minus 2. So I multiply the top by x minus 2, and what do I get? 5x minus 10. Minus 10 minus 6. So what does that give me? 3x plus 5x is 8x, and negative 10 minus 16, or minus 6 is negative 16. Okay, right now I can't reduce anything the way it is, but do you see that this, I can take an 8 out, which would leave me with x minus 2 over x times x minus 2. Now, can I reduce? Is there something I can reduce? 1 and 1. So I'm left with 8 over x. Okay. What if I had this? What if I had y over y minus 2 plus 8 over 2 minus y? I want you to look at what we did up here earlier. Here we had a q minus 1 and a q plus 1, completely different. But you remember that other part, that thing I taught you in 7.1? If they're the same thing, separated by subtraction, so y minus 2 and 2 minus y, I can change this to y minus 2 as long as I leave a negative 1. Well, that's fine, except I can't leave the negative 1 on the bottom because then it still wouldn't be the same. So I put the negative 1 on the top, and what it is you're multiplying. So you have y over y minus 2 plus a negative 8 over y minus 2. Denominators have to be the same, so they stay the same. Y minus 8 on top, put parentheses around it. There's nothing you can reduce, and that's your answer. All right. Am I still on? Yeah. Video or audio is still working. All right. Let's look at one more big one. Okay. What if I had x squared minus 25 over x squared plus x minus 20? Oh, nope. That's not the problem I want. Forget that. That's from an old one. All right, let's go down. That's not the problem I want. I want m plus 4 over m squared minus 2m minus 3 minus 2m minus 3 over m squared minus 5m plus 6. All right, I'm going to put parentheses. Right now, the denominators are two different things. But can I change their look? Yes, I can. This actually factors into m and m, 3 and 1, multiples of 3 that subtract to give you 2, and to get a negative 2, it would be like this. So we're not going to look at that anymore. This is the new denominator. And here, m and m, multiples of 6 that add up to 5 would be 3 and 2, and they'd both be negative to get a negative 5. We're not going to look at that. This is now the new denominator. Now, what would a common denominator be? You got to have everything represented. So you need an m minus 3, an m plus 1, and an m minus 2. And the highest exponent for all of those is just a single 1. M minus 3, m plus 1, m minus 2. All right. What do I need to do to go from here to here? I need to multiply by m minus 2. And whatever we do to the bottom, we do to the top. So I get m plus 4 times m minus 2 minus, what do I need to multiply this by to get this? Well, it's missing the m plus 1. And whatever we do to the bottom, we do to the top. Okay, so we now have 2m minus 3 times m plus 1. All right. Now we are going to need to multiply this out and multiply this out and make sure we consider the negative. Okay? So on the bottom, denominator has to be the same and it stays the same. In the numerator, I have m times m squared, m times negative 2, negative 2m, 4 times m, 4m, 4 times negative 2, negative 8. Now, here, 2m times m is 2m squared, but it's minus 2m squared. 2m times 1 is 2m, but it's minus 2m. Negative 3 times m is negative 3m, and when you subtract a negative, you get a positive. And negative 3 times 1 is negative 3, but when you subtract a negative, you get a positive. All right. Now I can combine like terms. This is the denominator. Okay, m squared minus 2m squared is negative 1m squared. Negative 2m and negative 4m give me 2m. Minus 2m is no m's, plus 3m is 3m. And negative 8 plus 3 is negative 5. Now, the only other thing we could do is decide if there's anything here, does that factor? Well, are there multiples of 5 that subtract to give you 3? No. So it doesn't factor. So this is your answer. All right, that's 7.2. You need to give that a try. It's a long one. Give it a try. And I'll talk to you later. Bye.